Hi everybody, my name is Alexandra Lontz, or you could call me Alex. I'm a first grade teacher in the Central Dauphin School District. I just finished my third year of teaching, and I really wanted to pursue this endorsement in STEM to really help my students engage in real world problems. I've already noticed a lack of motivation in my classroom at such a young age, so I'm really hoping that this helps them engage on a different level. Some fun facts about me are I'm a dance teacher and I have a pet horse. I love to ride horses. So the first question I really looked at is, how do students learn science? And I really do believe that students learn science through inquiry, observation, engagement, collaboration, and reflection. In Chapter 1 of How Students Learn, the authors point out that learning really has two parts, that factual knowledge combined with conceptual knowledge. The example I thought of when thinking about this was addition. Students can memorize addition facts, but they really those facts don't have meaning if students don't have any conceptual understanding of addition, and they won't really be able to relate those facts to anything else. They'll just be able to memorize them. And I included the picture of Bloom's taxonomy just as a reminder that we can remember and recognize facts in math and in science, but they're not really meaningful. And to make those activities more meaningful for students, they should be able to understand the concept so that they can recreate it with something new. I loved this visual that Donovan and Bransford included in Chapter 1, and the ideas also come back in Chapter 9, that students learn best when instruction is learner-centered, knowledge-centered, assessment-centered, and community-centered. The biggest barrier to science learning, as pointed out in the readings, is prior knowledge. Even though, as we heard, experience is the best teacher, our students are really coming in with all of these misconceptions. The first misconception they have is developed from everyday experiences. I thought the example about the earth was really great to show that students have misconceptions about science already. Some kids think the earth is round and think of a ball. The earth is round like a ball. Other kids might think that the earth is round like a pancake. And these are all ideas that do need to be addressed before students can really learn science. And then another misconception is that science is what scientists know and not how they know it. So really getting into our students' minds and kind of fixing those preconceived notions that they already have. In my classroom, I'll be the first to admit that something lacking is really that opportunity to engage in scientific inquiry. Even though it's getting a little better with our monthly STEM activities, our curriculum doesn't really have a lot of opportunity for those observation, imagination, and reasoning skills. But something we do have is that metacognition, where students do engage in self-assessment and grade themselves with a rubric. My STEM perspective is very similar to the figure in Chapter 8.8 in Chapter 8 of What is Your Perspective on STEM, where I believe science, technology, engineering, and math should be integrated equally. And last but not least, my favorite candy bar is a Reese's Peanut Butter Cup.